Yeah, good evening, one and all. So, we are about to start today's session, session 1, day 4 of our ATAL FDP program, and we are privileged to welcome Dr. Deepanita Thakur as the speaker of session 1, day 4. And I'm very happy and very proud and very glad to welcome you in this FDP program. How are you?
I'm fine, ma'am. How are you?
Yeah, I'm fine also. So,
Hmm.
hope to have a great session ahead. So, the participants joining. Meanwhile, I will introduce Dr. Deepanita. Dr. Deepanita Thakur is currently an assistant professor research in computer engineering at the University of Calabria, Italy, since July 2023. Additionally, she is a visiting research scholar at the Missouri University of Science and Technology, USA, concentrating on energy efficient optimization within federated learning systems. Her areas of expertise include federated learning, green artificial intelligence, and smart healthcare systems using machine learning, where she has made valuable contributions through her research on sustainable AI practices and privacy preserving healthcare systems. Dr. Thakur possesses a robust academic and research background and has published extensively in esteemed journals and conferences, including those organized by IEEE and elsewhere. Previously, she held a long-term teaching and research position at Banasthali University, Rajasthan, India, where she successfully guided numerous student projects and theses. Her accolades include a patent for smartphone-based human activity recognition and the authorship of a book on intelligent activity monitoring. As an active member of IEEE and ACM, Dr. Thakur contributes significantly to the research community by participating on editorial boards, IEEE Census Journal, scientific reports, Springer Nature, etc., technical committees, and workshop organizing teams. Her research strategically integrates advanced AI techniques with practical applications, underscoring her commitment to sustainability and innovative impact. So, with this, I welcome you, and the session is over to you.
Thank you, ma'am, for your this kind introduction, and thank you for inviting me to speak. Okay. So, good evening, all of you, dear participants. Okay. So, let's start. Let me share my whole screen. Is it visible to all of you? Uh, Anybody? My screen is visible?
Yes, it's visible.
Okay, okay, fine. Okay. So today, according to the given topic, you can see this title, that is Green Aware AI in Smart Healthcare. So here we can see two different terminologies. Those are very
Sorry,
popular nowadays. Yes?
make it full. Is it possible to make it full screen, like presentation mode?
No, it's PDF file. It's PDF file. It's not
Okay.
it's a PDF file. Yes.
Okay.
So it's PDF file. So it is in full screen actually, whole PDF I'm showing you.
Okay.
The presentation is not in PowerPoint. That's why. Okay. So there are two terminologies associated here. You can see one is Green Aware AI and another one is Smart Healthcare. So according to this overview of this talk, so what we have always when we go through something, three things are there in our mind. That is what is this, why we are doing this, and how we are able to do this. This is the main three answers we need to perform any of the research work or any of the work. So, and then we will talk about the case study. So let's talk about first this Green Aware AI. What is it? Why these are nowadays very popular? you can see here the different clippings of the research papers, and you are able to see here this green AI term. And this is given by Professor Roy in 2020 only. That means the green AI concept started from this 2020, and later on people work on this green AI. So when we talk about the green AI, that means it's related with the environment. So that's why we are talking about this. It's nothing but a sustainable AI. When we would like to provide an AI solution, that is the sustainability. So what does it mean actually that we would go for this green AI or sustainability? That means when we talk about sustainability, three things comes in our mind. That is society, economic, as well as environment. So this green AI, impact of green AI related with the environment. So the sustainability in terms of the environment. So when this concept comes in the mind of the researcher, so that means if we have the green AI, that means we have the red AI as well. So what is the difference between this red AI and green AI? So according to the definition given by this first paper comes into 2020, they are saying that, okay, when you are using some of the models, normally when we talk about the models, it can be a machine learning, a deep learning model. And if you are train this model, so it emits huge number of carbon footprint. Carbon footprint consists of two different gases. One is carbon dioxide, another one is methane. So normally people are considering carbon dioxide more because it affects the environment more than the methane. So if it is emits more amount of carbon dioxide, that means your AI solution become red. And if it's emits less amount of carbon footprint, that means your AI solution become green. So this is the basic concept of green AI always related with the environment, that while train the model, how much carbon dioxide it emits actually. So now there are several questions in our mind, that why only in case of this model training, why not any other things? Of course, in other things as well, we always emit some of the carbon dioxide. If we switch on all the lights, ACs and everything, we have this problem. So that's why we are considering both hardware as well as the software. So when we talk, just because of we are more focused on software, that's why what we need, that whatever the algorithm or model we will propose, that should be the green one. According to the environment, it emits less amount of carbon footprint. And if I am talking about the hardware, so of course, hardware should be standard in such a way that it emits less amount of carbon footprint. So when we talk about this machine learning models and deep learning models, so actually, when we use this, almost all of us use every day, every moment nowadays. So we don't know, or without knowing, we use a model. That what is the reason behind to use this particular model? Maybe it's a machine learning or deep learning model. We don't know, because we have the data set, or okay, let's take the deep learning model. So we have to identify whether a deep learning model, it's really required in my work. That's deep learning model. It's really, it needs or some normal machine learning model, using some machine learning model, I can do this. Or sometimes maybe it's required that I have to go for a deep learning model, but without knowing, I'm increasing the number of layers. I don't know, maybe I'm taking the 3 convolutional layers or 2 max polling layers, drop down layer, and several things I am taking, but without knowing anything, that really I need this number of layers, because when I increase the number of layers, ultimately it increases the number of computations, right? So that's why we have to take care about this. So when this concept, the green aware AI, divided in two, that is green by AI and green in AI. So when we talk about the green by AI, that means we would like to provide, we would describe a solution that is eco-friendly with the environment. And that means it's smart mobility should be there. It's sustainable. It may be the smart healthcare or in agriculture, whatever. It's climate change. It's adaptability is there. Environmental policies, of course, we should not emit more amount of carbon dioxide. And when we talk about the green in AI, that means we have to optimize the algorithm. We have to design a hardware in such a way that it should be optimized. Data center, because nowadays we have big data centers, huge amount of billions and billions of data are there. So data center optimization and reducing the pragmatic scaling factors. Because always we go for this number of layers increasing and everything. So scaling in different ways, not only in terms of data. So scaling in different ways. So there are these two concepts. So we have to take care about these two concepts. But when we talk about the green aware in smart healthcare or smart agriculture, actually we have to focus on these two. And mainly as a computer science students, we should focus on this green in AI mainly. Then automatically my solution become the green by AI. So now the question comes that, okay, we are able to understand that what is it? What does it mean that what is the green AI or green aware AI? So then why we are so focused on this? So if you see this diagram, is it visible to you? I think so. Not very prominent, but anyway. So you can see here the computational demand of the modern AI. Always we are talking about the smart cities, smart healthcare, smart agriculture, everything should be smart. So when we talk about the smart, that means it's able to take the decisions automatically, is able to do the things automatically. So that means it needs a huge computational demands we have. So if you see from the 1960 until 2020, so you are able to understand the increasing of it the last 50 years, the step. Everything in computer vision and natural language processing and games and others, whatever, always we need to train a model according to ourselves, according with our data set, and we are able to compute something. So it's huge computational demands we have. So the source of this, and I'm not saying this, the figure is given by OpenAI, the economist. So we have to rely on this, that we have a huge AI computational demands and modern AI computational demands, and people agree with this. And here you can estimate this blue colors. If you are, it's visible, it's blue color. It's saying the carbon dioxide equivalent emissions of training ML models. So you can see this scenario. And in brackets, if GPT-3, 175 billion parameters we have to adjust. So you can understand from this that how much parameter, why I am talking about the parameter when we talk about the machine learning and deep learning model. If I take ResNet 50, so it's 25.8 million parameters we have in this. So that's why we are dealing with the machine. While training, machine is dealing with this amount of parameters. So it's computation. You can estimate the computation in such a way that how many computations it's required. So that's why carbon dioxide emission will be much more higher. And the violet colors, these are all real life cases. So real life cases means that if I compare one particular model with the real life scenario in the next, you are able to understand this very easily. If you study this and approximate, so you can understand that what we are dealing with each and every day, and how it impacts the environment and how it will be harmful for our next generation. So it's saying that GPU-based deep learning NLP model leads 600,000 pound carbon dioxide emission. And if I measure it with the real life scenario, so it's nothing but the carbon emission by the 5 cars throughout their lifetime. So if I think about the lifetime of 10 to 15 years of a car, so 10 to 15 years, 5 cars, you can imagine how much it will be. So similarly, another one, you Google AlphaGo, it's also the very carbon dioxide it emits. So these are very big examples, right? But if I consider only the ResNet 30, ResNet 50, so it's deal with several number of millions of parameters, and the emission of the carbon dioxide is huge amount. So in a previous FDP, that was in JP Institute of Information Technology, Noida. While giving the introduction, and after the introduction, the dean of that department was saying that, okay, we have purchased one supercomputer. So I am eagerly telling all my faculty members, because all the faculty members are the participants of this FDP, of that FDP. So they should use the supercomputers. So there is one question, that should I need it really for my data set? Because running a supercomputer without the need of it, because suppose you have such data set that you don't need that GPU or supercomputer, and you are using this, that means you are running a huge hardware, it emits a huge carbon dioxide. But I don't need this. But I am saying, okay, I have done this experiment in using the supercomputer. You have done this experiment using CPU. So but I have to establish the relevant proof that whether should I need this supercomputer to execute my experiment, my data set is such a way, or my model becomes such a way that I can use that supercomputer. So that is the question. So without knowing, we used to use all these things, but it's tremendously bad impact the environment. So that's why we are focusing on this energy efficiency, that is the green AI. And always this green AI means related with the energy efficiency, because ultimately it's related with the computational and communication cost. If I reduce this two, automatically my system become energy efficient. How? I will show you. And then it become energy efficient. That means I'm able to go for a solution which become green. Now, there are some questions regarding this that now tell me that in science, when we talk about the red AI and green AI terminology I am defining, I am not telling you some of the threshold value, that what will be my carbon dioxide emission, right? Till now, there is no standard. That is one of the challenge. But it depends on my application. So nowadays, you have seen that when you book the flight ticket, you are able to see the cost, price, ticket price and everything, and you are able to see the list of the flights. And in there, one option is there, how much carbon dioxide it emits from source to destination. So that means there must be a standard. If I have, suppose I have money, I want to go for a company, and I have one flight that will run from Delhi to Kolkata. So now I am able to get the license after this testing, that how much carbon dioxide it emits. There are several testing. That is one of the part I am talking about. So so that means there is some standard, but the amount is not defined, because it depends. How, suppose the distance is much more, so a carbon dioxide emission will be more. Its distance is less, it should be less. So it depends on the situation, depends on my solution, that what will be the threshold value of this emission of the carbon dioxide, so that I can say that my model, my solution, AI solution, become the green aware. Okay. So now another terminology we have, that is the smart guidelines. That is the smart one, because I am talking about the smart healthcare. I will talk, but this thing can be for the smart agriculture, can be for the smart city. So here my case study will be based on the smart healthcare. So the smart guideline, that guideline is given by who? World Health Organization. Each and every 5 years, who publish one report, and with the report, who also giving some guidelines. So this smart guidelines, what we have the acronyms for all this, all the letters, individual letters. So S, standards based. So standards, that means I have several standards, and one of the standards should be related with this emission of the carbon dioxide. That's why I put it in a green. So it is standard based, of course. Machine readable, it should be, otherwise how can it become smart? Adaptability should be there, A. Are requirement based, of course, according to the requirement, I can, my smartphone, according to the requirement, I can install any of the application and I can use it. Of course, testable. Otherwise, we are unable to say that it meets some of the standards. So these are provided by the smart WHO regarding the smart guideline. And WHO is saying that if you have to follow this pathway, then only you are able to achieve a smart digital system for any of the application. It may be for healthcare or maybe for other things. So if you see these layers, there are 5 layers, L1 starting with the paper systems. And then after L5, it's showing, the arrow is showing the smart digital systems. That means my system should be narrative guideline should be there. That means evidence-based guideline recommendation. Operational, of course, it should be human readable. Then it should be L3, it should be machine readable. It should be executable. That means I need some software that must be executable, reusable. It is able to adapt the things, and of course, the dynamic. That means scalability is there, and it execute the algorithms dynamically. So these are the 5-step pathway we should follow to become a system smart. So this is provided by the World Health Organization. Now the question is why we are talking about this smart healthcare. Someone is raising hands or what? It's okay? Yes, someone is raising hands. Do you want to ask something or what? No, it's okay. Is it fine with you, Shohel? Okay. Do you want to ask something? So you can put it, if you are muted by the organizer, so you can put it in a chat. We will discuss everything. Okay.
Yes. Interaction can be later.
Okay.
Yeah.
Okay. Talking about the electricity. No. Not only the electricity. It's not my part actually. Electricity, I am using the electricity should be, I should use, right? But my electricity providing devices should be the green one. So there is no role of the computer science people in this. But what I can do, I can design my machine learning model in such a way. I will show you that what are the possibilities. Actually, you are able to understand this talk is related to, I have designed in such a way so that I can give you some research gaps you can work on if you are interested in this area, that my system will be a green aware AI solution. It can be any solution, not only the smart healthcare. So that is not my part. I am talking about that while train a model, it emits huge amount of carbon dioxide. So how I can control this? I have to do this, that as a ethical AI practitioner, I have to do this. So that's why I will show you that how we are able to do this. So what can be the possibilities? So this is the scenario that I am talking about here. That means only the model training, while train the model, how much carbon it emits. Okay. So now what we are talking about, this smart healthcare. So you can see from this diagram that Technavia is the one of the company that always do the latest market research based on the global smart healthcare market. So this research is based on 2024 and 20 between 2028, the prediction, of course, based on the previous one. And you are able to see the incremental growth in case of this smart healthcare, $125.7 billion. So each and every country, it is the estimate of based on the dollar. But if you talk about India as well, so the government is spending too much money in case of this smart healthcare, because we need each and every country need it, because you know that we need the remote healthcare monitoring system, remote patient monitoring system, telemedicine, everything, because we don't have sufficient number of hospitals, sufficient number of doctors patient ratio is very bad. So these things are there. So we need always the remote consultation, remote habilitation, everything. So that's why people are focusing on this smart healthcare as well as the government. So that is the reason we are talking about always smart healthcare. Nowadays in US also, people are very much focusing on this smart healthcare. There are several projects by this NSF as well regarding the smart healthcare. So that's why we are focusing on the smart healthcare. So now let's talk about that. What are the implementation problems? So we can understand that, okay, what we have the smart healthcare, we have to go for the green aware AI. And then why we are concentrating in this green aware AI in smart healthcare? I think somehow it clear that yes, we need the smart healthcare. Everybody knows. And when we talk about the smart healthcare or smart things, so we know that several things comes in our mind, that IoT, cloud, big data, then machine learning models, deep learning models, like this. Without these things, our system can't be smart. We need all those things. Okay. So what are the implementation problems? The first one already I have discussed, that is the high energy consumption of AI models. It's true. You can check also using a very small CNN model. I will show you that how you will check. Huge emission of carbon footprint, of course. These are related, energy consumption and carbon footprint. And we have the data privacy rules given by the government. HIPAA, that is the Health Insurance Portability and Accountability Act of 1966, it's followed by the US government. And GDPR, that is the General Data Protection Regulation, that is followed by European government. So they have the data privacy rules. That means here, if I talk about the smart healthcare, not only smart healthcare, it can be applicable in any field, but the first one is related with the health for US, that we don't want to share our health related data. And you know, some of you may be working on this health related, we using this health related data. So, and you know that it's very difficult to get the health related data. So just because of the reason is that it's a data privacy we have. And of course, we don't want to share suppose I have ultrasonography report. I don't want to make it public. I have some MRI report. I don't want to make it public. So data privacy rules given by the government always, we don't want to share the data. And when I talk about the smart healthcare, that means I am sending my data set to the cloud, right? So so it's very easy to access. So we have to maintain the data privacy rules in any case. Decentralized processing, of course, in the smart healthcare, I need this. Maybe there is one Apollo hospital, Apollo group, and Apollo group is there in the Hyderabad, in Chennai, in Kolkata. So I need the decentralized processing, because then it can be adaptable or scalable, because if I need the different AI solutions for different same groups, different hospitals, so it's not the good thing, right? So we need the decentralized processing. Sustainability in terms of economy, sustainability in terms of society, sustainability in terms of environment. And when we talk about the in terms of environment, it comes under the green area. Okay, real-time AI in wearable and IoT devices. This is another issue, that is another challenge, that always use amount of data. I have the IoT devices, edge devices and everything, or wearable sensors. So use amount of data, always it's coming real-time data. So it's another challenge to handle it, that while offline data I am able to handle offline, it's okay, fine. But when it's related with the smart healthcare, always we have the real-time data to deal with. So it's a big challenge. It's a great challenge. And green AI standards in healthcare. Why it is a problem? Because they don't have given any particular threshold value, particular standard, right? So I told you previously that it depends on my application. Suppose one Apollo group has 50 different hospitals all over the country of India. So if I calculate total carbon emission, it will be high. And if some small hospital or a small nursing home, so it should be less, right? And I'm considering the total carbon dioxide. So it's considering electricity, power, everything, backup, everything. But here I am focusing on one of the AI solution. If I want to give you, then it should be using the machine learning, deep learning model. So it should be the green AI, meets the green AI standard. So there is no standard provided by any of the organization like WHO. They are saying, okay, less and higher. So that is one challenge, that how much it will be. So you can ask someone that, okay, you are saying your solution is green. So how much it will be, right? So there is no amount. People are, till date, people are unable to tell you the amount according to your requirement. So you have to compare that, okay, I am improving my system. That means I am reducing the energy amount of carbon footprint. That's it. Okay. So these are the implementation problems we have to take care about. So what can be the solution? So what we need? So we need a solution for AI system to make it smart and smarter, that preserve data privacy. This is the most important if I'm talking about the healthcare. It should be energy efficient. That means it emits less carbon dioxide. It should be decentralized, of course. Scalable. Now Apollo has 50 hospitals. Maybe tomorrow it has 100 hospitals. Adaptable. Whatever it's there in the software solutions is able to adapt all the rest of the 50 hospitals. Reusable. It's not like that, okay, initially I have 10 hospitals, so I have one model, I have one algorithm, and again I have 100 hospitals, so I have to change everything. No, reusable. Of course, sustainable. Okay. So, and this sustainable is directly related with the energy efficiency. If I talk about sustainability in terms of the energy efficiency, because I can't give you that solution that, okay, my system will be low cost. It should be low cost, right? So economically, and it will not harm the society. So in other way, if I talk, if I don't consider this environmental issue, some other way, right? If I have a banking system, but it harms the society, maybe my banking system become hacked and my account, I have finished all the money, right? So that is harmful for the society. Okay, so these are the things I need. So now what can be the solution? How? Now the question, we are able to understand why we need, what we need, but then how? So there are several solutions for it, but I am talking about that what I am working on. So I have experimented with the evidence. I can show you my solution. One of my solution can be federated learning framework. And nowadays, you know very well regarding the federated learning. Why I am giving this solution? Because already federated learning consists of this characteristics. Distributed, it's nothing but a distributed machine learning framework. So I am able to get the distributed concept. Privacy preservation. So I am able to achieve the data privacy. Collaborative learning. I am able to, that means collaboratively, I am able to run the system. Heterogeneous. This is good characteristics of this federated learning. But there are some challenges as well. We will come to that. It must be communication efficient, because when I'm talking about federated learning, the network comes under it. So that means it should be communication efficient. Resource constraint environments, because you know nowadays people are working with the edge devices, tiny devices, because I don't want to go for any of the huge device. I can, my suppose smartphone or smartwatch is able to compute. That means what? It enables to run that particular machine learning, deep learning model, and its resources are limited. You know that its memory constraint is there, power constraint is there. So we will talk about the small tiny devices as well. So resource constraint environment I can support using this federated learning framework. Of course, scalable. I can increase the number of clients, and of course, robust. So in somehow these characteristics are there in the federated learning. So we would like to focus on the federated learning. So after with several experiments on federated learning, I am able to achieve something that I will share with you. How much time I have and total? Ma'am, how much time I have?
We can continue up to 7:30. 7:30 we have
Okay.
started. 7:30 we have another session.
Okay, fine. So if I go for this federated learning definition, so this is the very well-known definition. From the definition, you can understand it's not very old, 2016, introduced by Google first, in which multiple devices collaboratively, that means collaborative learning, learn a machine learning model, of course, without sharing their private data privacy, under the supervision of a central server. Not always central server. This definition is the first definition given by Google when they only focused on the centralized federated learning concept. But nowadays we have the decentralized one. That means I can have more than one server as well. Okay. So based on this, if we see this diagram, this is the basic one that is given by the Google, and based on this, people work on this. So there is a good diagram. You can see here different clients. You can see here the laptop, your mobile, smartphone, and everything. These are different clients. There is one global server, FL server. This is the aggregator. So how it works? The global server, first step, global server share its global model to the participating clients. Now there is one big challenge here. Not all the clients always able to participate, of course, because some of the clients sometimes not live. Some of the clients are unable to participate because they are slow. Some of them are fast in comparison. So it's not possible to take all the clients together in real scenario. For the experiment we can do, but in real scenario, it's not possible. So some of the clients means what? Randomly, initially when 2016 Google given this concept, so randomly it selects the number of clients. So there are major challenges, disadvantages here. I will come to that if time permits. So, okay. So, and then it shared the global model to the participating clients, and all the participating clients will receive that model and train that model with their local data set. They will not send the data to the cloud for the processing. It has its own data set, different data sets. So it's process it and it sends the parameters of the trained model to the global server for averaging. That's why initially I was focused on this number of parameters to train a machine learning model, because it sends all the parameters to the global server to to get an average value of the parameter, and then the FL server again send the global model with averaged parameter to the participating clients. And now two things are there: number of communication in between the clients and the server, and another one is that is your local training epochs by all the clients. Okay, so maybe I am talking about, okay, 50 epochs for all the clients. Some of the devices are slow, so they are unable to complete 50 epochs in a certain time period, so unable to participate in the next round. So it happens. This is also a major challenge here. So this is the federated learning concept. So there are several types of federated learning, but these are not the exhaustive one, because I told you that decentralized, centralized, this is not mentioned here. We have this horizontal, vertical, federated transfer learning, cross-device, cross-silo. This is not the exhaustive list. These are some of the types, because based on the requirement, people divided this federated learning in different types. Okay. So what is the horizontal federated learning? I have the same feature set, but my samples are different. Suppose if I am talking about person A, person B, person C, so 3 different sample set, but my features are same for all. So that is the horizontal one, easy to deal. Problem with this vertical federated learning, where my feature sets are different and subjects are same. Okay, so that means horizontally somehow it's person A's data, person B's data, person C's data is there. So I can give you one example using this smart healthcare. Suppose Apollo group of hospital I am talking about. So Apollo Hyderabad is good in some of the disease, suppose gastro. And suppose, for example, Delhi is good in cardio. And I am one of the patient that I have 2 problems, different problems. Sometimes I visit this Hyderabad, sometimes I visit Apollo Delhi. And Apollo Delhi consists my heart related data, and Hyderabad consists my gastro related data. So I am the person, the same, but I have different features. The feature set is different in Hyderabad for me, as well as it's different in Delhi for me as well. So that is the vertical one. So in vertical one, we have horizontal as well, because I am not only the patient. Maybe some of the patient are there, they never visited this Hyderabad. So they don't have the gastro issue. So they have only this heart related disease. So the features are same for, suppose 3 persons are related with this heart problem. So they have the same features. And if I talk about the federated transfer learning, so then it's combination of both. That means what? I have, maybe it may possible that 2 things are different. I have different feature set as well as different sample set, different levels. So when I can go for federated transfer learning? Number 1, most of the data are sometimes unlabeled. If I'm talking about the real-time data set, so it's not labeled. Unsupervised learning I have to apply. So that means I have to, the data set is or semi-supervised. If I have the much number of data labeled and less number of data unlabeled, so I can go for the semi-supervised as well. So scenario is this, and tremendously I am getting the huge amount of data continuously I am getting. So that is one of the another reason. And I have the heterogeneity in terms of the system, in terms of the data. Because all the devices, if you remember the previous diagram, so all the devices are of different configurations. My laptop, my mobile, my smart watch, everything, they are different configurations. So this is known as the system heterogeneity. And the data heterogeneity, of course, because I'm saying I have this this disease, so my feature set are different. Someone is saying that they have this type of disease, so feature sets are different. So these are the difference here. So then only we are able to go for the federated transfer learning. And nowadays you may heard that knowledge distillation is one of the best, one of the very good solution for this federated transfer learning. The concept is based on the student teacher. But here there is another challenge regarding the data privacy, because when I talk about the transfer learning, that means some of the data should be shared in between the clients or in between the client server. So this type of architecture we have. So that means somehow it that is the data sharing is permitted here. So that is not supported by some of the standards, that we don't want to share our own data. But yes, because always we have to maintain the trade-off. So some of portion of the data we can share. Okay. And the cross device means I have different types of data. The diagram devices, the diagram you have seen earlier, my data, my clients are different. And this is the cross device and cross silo. I have, it's very difficult to implement. We are working on this because a smart healthcare, its cross device is not the real solution. I am talking about the different organizations. So different organizations, it may be different hospitals as well. So these, when we talk about the different organizations and different organization in terms of disease, maybe one is related with eye related issue, another related with the heart related issue. So these are different organization, different set of features, different set of samples. So this is the cross silo. So it's very difficult to achieve. Okay. So now green aware in smart healthcare, that means I have given the solution for some of the characteristics in federated learning. So what I have to go for, federated learning plus sustainability, or we can say federated learning plus energy efficiency. Then the system become the green aware. So now federated learning based healthcare system, if you are able to see this diagram, so you can understand that first client, that is the smart home healthcare, this one, this is the smart mobile healthcare, and this is the smart hospital healthcare. So each has its local data. So we are not sharing the data. So here the devices are different. So heterogeneous, it has its own different data sets. So data heterogeneity. So in case of data heterogeneity, two things are very important, that whether my data is IID, identically independently distributed, or it's not identically independently distributed. So suppose I have a data set. I want to share it among the 5 or 10 clients. So what I will do, that I will give all the features to all the clients. So that is the identically independently distributed. And if it is not, maybe some of the clients are getting some of the features and some of the clients are not getting some of the features. So that is the non-IID scenario. And we have to deal
Hello, everyone can see slides?
No, I guess she is disconnected somehow.
Yes. So, okay, I am sending message. Maybe she is aware or not. Speaker has joined. Hello.
No, madam, not.
Okay, I have sent message and also email. Actually, if you can try in WhatsApp call. Actually, the
Okay, I'm trying
speaker
to.
is yeah presenting from USA. So only way to connect her is the WhatsApp call if she receives. So Sohel, please try. And sometimes what happens, like while you are giving the online presentation, uh, the speaker is not aware that the connection is broken or connection is low, video is not means the presentation is not working. So just wait for a while and session will start. Yeah, now yeah, Dr. Deepanita is back. Yeah.
No, no, no. Actually, so can you share the screen? I am in mobile now. So are you
Okay.
able to share the screen? Because I have sent it already you that particular
Yeah.
PPT. Yes.
Yes. Yes.
Is
Yes.
that the same slide you are using?
Yes.
Yes, from your
If
mobile
you
also
can
you can.
share. No, no, it's not in my mobile. That's why I think if you have, then you can. I can share with my mobile,
Yes.
but I
Yes.
have to.
Yeah. It's in email. I think. Well, can it be shared? Subhashish or
Let,
anyone can share it.
let me just give me a moment.
Yeah. Yeah. Sure. The device to be ready for that. It is in email. So meanwhile, if any interaction or any question is there, one or two
Yes,
could be
till now,
taken.
if you
Yeah.
have any question, you can ask. Uh,
Dear participants, if you have any question, meanwhile, you can raise your hand and that could be taken.
So which slide?
so yes, yes, come to yes, good. So I was in the slide number 23. 23. Yes. Yes, in this. So those who are working with this privacy security issue, so you can understand is there is one hacker that hacks this particular um the particular the global server. So it's not only that it is able to. Am I audible to you, Shoel?
Yes,
Yes, you're
yes,
audible.
yes,
Okay,
yes,
fine.
audible.
So
And
okay,
there is a hand raise from Dr. Shantanu Shah. Will you take it
okay.
now?
If you want, yes,
Yeah,
yes, no problem. No.
team, please unmute Dr. Shantanu Shah.
Hello, good afternoon, ma'am.
Good afternoon.
Ma'am, yes, ma'am. I have a very simple question. The federated transfer learning, is it similar to federated learning, the same thing?
No, 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 no. Federated learning is the basic concept. Now we design use that federated learning framework in different ways as per our requirement. So whenever we go for why we go for federated transfer learning, if I would like to deal with 3 4 things simultaneously, that yes, I have heterogeneity in terms of system, in terms of the data as well. If I have this continuous data is coming and I have to deal with it, and then I have this issue that some of the data set are not properly labeled, then only we can go for this transfer learning. So that means transfer learning in federated learning concept. So I'm mixing this two. So then only we can go for it. Otherwise, if we don't need this, because suppose my data is not such heterogeneous, or there is no question of such real-time data handling. So this type of things, if we have, then we don't go for it. Is it clear?
Okay, ma'am. Thank you.
Okay. So now you can see here that one hacker, so it can hack this global model. It can also hack the client as well. But the thing is, we are considering that, okay, federated learning is supporting this data privacy. But the thing is, nowadays, it's proved that if someone is able to hack the gradient, because in the parameter, when the client send the parameters to the global server, it calculates the gradient using for the optimization. It always calculates the gradient. So when it calculates the gradient and sends the gradient, and someone hack the gradient, and using the back calculation from the gradient, they are able to get the data set. So someone can deal with this. So people are working on this area as well, that how we are able to achieve this, that my gradient will be not exposed to the hackers. So this is one of the very good area to research on. Pritam, someone is raising the hand. Do you want to ask something? No. Okay. So this challenges, actually I am able to find out these challenges in terms of effectiveness and efficiency. That when we talk about the effectiveness, that means we are dealing with this heterogeneity concept. That may be statistical, maybe the system I told you initially. And these are the solutions, that data moderation. If my data is heterogeneous, that means I am dealing with the non-IID settings. Personalization, this is another solution. And clustering, this can be the other solution. And when I want to deal with the system heterogeneity, so bridging the divergence of the local model, because my system is heterogeneous, they are from different configurations. So that means I would like to deal with the local model divergence, because when I go for the calculation of the gradient, why should I go for the gradient calculation? Because I would like to optimize my model. So when optimizing the model and the basic federated learning framework, if I take the stochastic gradient descent, so it's giving the variance in the gradients, different models, different clients, different computational complexity, and that's why they are different. Asynchronous FL scheme. So I told you initially that it's not possible in real scenario that all clients are alive at the same time, or all clients want to participate the same time, or all the clients able to participate due to their configurations, they are different. So that is the asynchronous FL scheme we have to consider. Similarly, in case of efficiency, and this is the area I am really focused on, that is the communication overhead and computation overhead. So client selection is one of the issue. I told you initially, it's never possible that all clients will participate, and random selection is sometimes very dangerous. Why? In case of random selection, what happened, that I am selecting the client randomly. That means I can miss some of the client which consist of a feature set that are not in the other client. So that means my system unable to not totally, that is adaptable or totally robust. So this can be very dangerous. So we can suggest some of the client selection. Model compression, we can reduce the model with different pruning strategy or sparsification or quantization. We can mix these two. Number of rounds of the communication in between the global and local models, clients. So it should be reduced. And communication overhead, model distillation. I told you initially, knowledge distillation. Again, the pruning as well. So these are some of the solutions we can work on. So here I would like to give one of my work. This is a very simple, that I quantize my model. So you all know that nowadays we have 32 or 64-bit machine. laptops. So if we have the 3264-bit machine, and when it computes, you know that if you are designing a very simple CNN model, each and every layer, there are several computations. So multiplication and all. So if 32-bit floating point, it takes the 32-bit. So it will compute for the 32-bit into 32-bit. So it become complex. So what can be the solution? That we can quantize the number of bits, number of precision we can reduce. This is very simple. So I have distributed my human activity recognition data set in non-IID fashion, and then I have applied this quantization to C. So this is the federated learning design, and here I have to consider the hardware as well. In which type of hardware I am computing this? Based on this, I can measure the energy efficiency actually. So this is a very simple one, the simplest one. You can say that this is a diagram that multiply accumulate operation we have, because each and every layer you can see that weight, activation input, weights, these are there in my deep learning models. So here we can multiply, we are able to multiply the things, and how this hardware, if I take this generic hardware energy model, then how it works. So you can see here, I have taken the 2-dimensional CNN. And if you see the weight bit and activation bits, I am taking 32, 32, 32, 8, different combinations. This is the ablation study. And I am calculating the training time as well as my accuracy as well as my energy consumption in Joule. How I am able to do this very quickly, I am coming to that because this is the most interesting part. So these are the results. So you can understand that with full precision, energy consumption is much more higher. And with the 8-bit quantized weights, it's weights and activation, it's very less. Similarly, these are the accuracy and all. These are the diagrams. And here is the interesting one that we have both communication rounds and energy consumption and number of selected devices. Okay, so number of selected devices. So energy consumption in Joule, and you can understand that when energy consumption is increasing, the blue color, increasing while number of devices is increasing, and the communication rounds is decreasing when the number of participants are increasing. So we have to consider, we have to come to that particular things in between. My slides are not moving in your case. Yes, next. Nobody is saying. That means nobody is listening. So next, that is 31. I am at the end almost, 31. Next slide. Yes. So I am in between. So that means I have to consider this client selection strategy properly so that I am able to maintain the trade-off. So I would like to reach in between so that 15 number of clients is giving me the best solution. So I have to maintain the trade-off always in this scenario. So now how to measure the carbon footprint? This is the big question. So we have several tools or several Python libraries as well. So Code Carbon is one of them. That is the carbon tracker is another one. Code Carbon is a very simple library you can use. I can show you, but Shohel, can you click on that particular collab
Yes.
symbol? I don't think you are able to get the access of it. So
Yes,
because you don't have access to open my collab, no? Okay, in
Right.
any case. So you request me, I am giving you. So this, what Code Carbon, it's very simple one. So you give me the request, I am approving this. So you can run it.
Request is sent.
Okay, let me check. Okay. Yes. So let me talk about till then. It's I think I have given the access to him. Let's see. Yes.
It's still asking for access. You need access. I just refreshed it.
Okay. Okay. It's Shohel. It's not Gmail. It's
No, MAKAUT
It's your
WB.is.
office.
Yes, yes.
Okay. But some of them you are unable to run just because of the reason is the reason is that either you need one Intel CPU with that particular scenario where you have that nowadays Intel CPUs are coming with that interface, RAPL interface. RAPL interface I don't have in my PC. If you don't have, so you are unable to run this another one except the code carbon. And PyJoule, I have worked on PyJoule. It gives the in Joule. Are you able to get the access?
No, not yet. Still asking for request
Okay.
access. I am sending a request. Check
Oh,
this
you
latest.
don't have the full access to Google Workshop. Okay, it's okay. So you can, I can share with you so that people can run it by their own. So I will share the code with you. So, but PyJoule you can run. You are unable to run if you don't have the proper Linux system. If you have the proper Linux system, because it's don't support the virtual environment also. So you need a proper Linux system to run the PyJoule and the rest of the things. But you can run easily the code carbon. You have to import pip install code carbon, then you have to import it. And when you train, when you write the model.fit, I will share this code. You can run it very easily. So using a simple data set. So when you run that model.fit using this xtrain and ytrain and number of epochs, and before that you will start this code carbon and then stop this code carbon and then print this value, so you are able to get the amount of carbon emission as well as the power consumption in kilowatt. So code carbon giving me the in kilowatt and PyJoule is able to give me in joule. The experiment I have shown you previously using the PyJoule. So that's why the power consumption, energy consumption is in joules. But power top and carbon tracker, you are unable to run if you don't have either NVIDIA GPU, this supports NVIDIA, and also NVIDIA, and also that CPU with your RAPL interface. That means energy interface should be there with the Intel CPU, then only. So that is then the last slide. Next. So this is my conclusion, that interesting areas to explore. I given you some of the hint related with privacy and security, and people are working that how hackers is able to hack my whole data set using hacking the gradients and federated averaging algorithm. This is one of the work I have worked on, the federated averaging algorithm, because simple averaging fed AVJ given by the Google. But federated averaging, I can, based on the data quality also, what I have done in one of my experiment, I have taken the entropy of my data set, calculated. And based on the entropy, I am able to find out the quality of my data. And based on that, I am doing this federated averaging. So I have proposed a new algorithm for the federated averaging. And heterogeneous quantization, the work I have shown, that is the homogeneous quantization. Because of all the clients, I am taking the 8-bit activation bit and the weights for weights. But it's not the actual scenario, because my different clients are there. They are heterogeneous, right? So same quantization if apply for all the clients, so it's not worthy. So I have to go for the heterogeneous quantization. So very little work has been done in heterogeneous quantization. So this is another area. Next, non-convex optimization, because when I am talking about this whole system, what is my ultimate objective? I would like to increase my accuracy and also reducing the loss, right? So loss, when I would like to reduce, so I have a loss function always. So when I have a loss function, I would like to reduce this value. And suppose I am talking about the cross entropy as a loss function. So cross entropy loss function may be convex, may not be convex. So normally it's non-convex. That means non-convex means I have more than one local minima. Non-convex. So this is the real scenario. If I have a single minima, local minima, so this is the convex scenario. So actually I have more than one local minima, so I have to find out the global minima. So that is the non-convex. It's very difficult to prove in the non-convex optimization. So also I am dealing with this non-convex optimization, asynchronous FL, and of course the cross silo environment, which we need in the smart healthcare, of course, because different hospitals, different organizations, and it can be many more. So these are the things, because I can share you some of more things, but I have cut short because I have a limited time period. So these are some of my work, and one work that is for this green artificial intelligence. This is for the someone else. So these are the work that already I have published related with the green aware AI with the
Please
federative
change
learning.
the slide and please change the slide. It's in conclusion. Yeah.
So these are some of the references. Most of them are from myself. So these are some of the work. And now you can feel free to ask some questions if time permits.
Yes, time is there. Next session will start by
Okay.
7:30. First of all, I would extend the sincere thanks to you for covering all these optimization problems that you are working upon. And it is obviously unparalleled, these area, because the models, the algorithms that are being discussed for last 3 days. And this is the another area where the participants, if they are interested, then they can obviously work upon and start doing research, or somebody maybe already in this domain of research. So with this, now the interaction is open. So participants, you can either raise hand, or you can just raise hand, and you will be unmuted for interaction. Okay, so I guess, yeah, Dr. Shantani Shaha.
Okay. So, ma'am, when you were saying that when multiple organizations, like multiple hospitals or different similar organizations, try to integrate through the is the cross solve, what you were saying, is it able to solve that, integrate those various format, when the data of various format, is it able to integrate that data?
Or yes, not only data, also the system as well. So already people are dealing with the statistical heterogeneity that is related with the data set, different kinds of data. And that's why we are focusing on this. Not only that the data is with me, that's why we are focusing on this federated learning. So that the different organizations with their own different data sets are able to handle under a single central server or more than one server. So there are challenges with the single server. So suppose if I am talking about, okay, I have two different groups of hospital, Fortis as well as Apollo. So maybe I can deal very efficiently using two federated learning server, one for the that is Apollo group, another for the Fortis group. So that much I need. Otherwise, I can handle it very efficiently.
Okay, okay, ma'am.
So we have another
That
question
means
from
centralized, not centralized one, distributed.
another question is there. What are the challenges faced when RAID AI turns into Gain AI? And what are the
So
challenges
already
faced
I
due to
can,
everything?
Red AI become green AI.
Yes.
Is it? Yes,
What are the
already I
challenges
have
faced
discussed
when
from the
red AI
beginning.
turns to green AI?
Yes, already I have discussed it from the beginning that energy efficiency, that challenges are several. Like when I reduce, suppose I am going for the compression of the model so that my model consume less energy to calculate the things. So it may be possible that I have to compromise with the accuracy, but I don't want to compromise with the accuracy. So I have to maintain the trade-off. So that's why from the beginning I am saying that I have to maintain the trade-off. This is the big challenge, that I have to number of participants. If I am saying that, okay, my less number of participants, so of course the energy consumption will be less, but it's not but the participating less number of clients means another challenge. That is, it may be possible that with some features I am unable to train the global model. So these are several challenges. I'm given only two examples. Already some of them I have discussed. So these are several challenges we have to face, that we have to always maintain the trade-off. Not only I am reducing the energy and my loss become much more. So that is not considered, right? Acceptable. Any other?
Yes, another question is there. How to manage the situation when available data not clear or vague?
See, here the data were not available or vague. Vague data means what? It's because if a technical definition of vague data is very confusing. So you can say that if I have noises in my data set, maybe some client has been hacked by that particular hacker, so that the data has been modified of a particular client. So I have to, that means I have taken care about all these measures, that uh, all these things I can able to understand if I have a robust system, that whether all the clients are participating with the proper data set based on the gradient values, based on the gradient variance. People are working on that as well. The gradient variance, because each and every time while computing the model, I am computing the gradient magnitude. And if I compare the previous rounds and next round gradient magnitude, I am able to get the gradient error. If my gradient error is something very abnormal, I can understand that client can be become malicious or anomalous. Not necessary all the anomalous client become malicious. So I will not I exclude that particular client. So my system will be robust in a such a way. And if it is also always possible that when I go for the non-IID distribution, if I am taking the Dirichlet distribution and non-IID distribution, so it is possible that data set is imbalanced. The first thing what you are saying, so data set is imbalanced, so I can use that GAN to generate the synthetic data, or I can, if it is small, then I can use the SMOT to generate the synthetic data. This type of things I can consider. Otherwise, if it is vague or something very different, so it ultimately harms the global model performance. So I have to exclude that client particular in federated learning scenario. Or if it is not a federated learning scenario, so I am able to, if I have a single machine learning model, so from the performance I am able to do this. So I have to take care about my data set.
Participants, is there any other questions?
Hello, good evening, ma'am.
Good evening.
Ma'am, I have one question. Suppose I have already trained some models using in the deep learning, like ResNet, different transfer learning model. Can I apply this carbon footprint method to measure the on the?
Yes,
Okay.
we
So
should.
after,
We should.
okay,
While
okay,
suppose you are not going for this federated learning concept, you have a simple VGG16 or any ResNet 3050, whatever you have. So
okay,
you can use this code carbon. I will share that code. with the organizer, they can share with you. So you can use it very easily and you can get that particular amount of carbon emission while train the model. So you can understand from it. A very simple CNN model exhibits such carbon dioxide.
Okay, okay. Then after measuring the carbon footprint, and then after that, I will optimize the parameters. Then we
Yes.
can measure, like if there is a reduction in the carbon footprints or not in the
Yes,
model.
not only the parameter, there are several things. Parameter optimization is one of the solution. There can
Okay.
be several solutions by which you have to reduce the emission of the carbon dioxide. So then when you apply your novel idea and then you code it and run it, then while training, you are able to see the, again, you can measure the carbon footprint. So you are able to compare this two, that before
Yes,
applying this technique, what was my carbon emission and now what will be my carbon emission.
yes, yes,
Yes.
yes. Okay, thank you very much, ma'am. Very nice session, ma'am.
Thank you. Anyone else? What I would like to say you, if you don't have any other question, that there are several areas to work on. Each and every step, you are able to get some of the novel things to work on, research gap. So it's a huge area you can explore so that you can work on. Yes, Ullash. Unmute,
Question
Shoel.
can ask a question.
Yes. Yes, you can ask. You have been unmuted by the.
Please ask the question.
And if you need any help to start on, you can contact with me. I have given my email ID as well as other platforms to contact with me. So you can contact. It's a very interesting area. Those who are good in mathematics, they can work on this non-convex optimization and convex optimization. There are several things to do in this area as well. Okay.
Hello. Ma'am,
Yes.
one more question. Ma'am, if we want to reduce the carbon emission footprint, so what are the methods? Like parameter optimization is one of the method. What are the others?
I have shown you almost all the methods, but I am unable to discuss all the methods just because of time limitation. There are several methods. Ultimately, what you have to do, you have to reduce the communication and computation cost, complexity, both two things. So now it depends on your system. Suppose you are going for this federated learning. So communication over it is always there. So if you reduce the communication over it, because it's sending the all the parameters to the global server, so it becomes somehow energy efficient. If you reduce the computational complexity of the model, if you are reducing its, maybe nowadays people are working on the split learning also. Split is another area. So that means in split learning, what you are doing, you are splitting the whole system because you have the layers, right? So you are able to see all the calculated parameters. So that you would like to send. So while computation, the local training 50 epochs, so actually what you need to converge the model. That means when your loss function, loss value becomes stagnant, it's not reducing. That means my model has been converged. So it may be possible that model converge in 50 epochs or model converge within 10 epochs. It is possible. But I have to, somehow I have to do something that my model is able to converge within the 10 epochs. So that
Yes,
means
sir.
energy, that means its computation complexity become reduced. Another one, model quantization, model pruning, model sparsification. So this type of things I can go for. If I am going for this federated learning framework, number of client selection, it will be in such a way that I am able to get the trade-off. But remember, there is one trade-off. This terminology. It's not always possible. My energy will be reduced. My accuracy will be too high. Everything I am able to get. No, it's not possible. So, but how much I will compromise with the accuracy? Not more, because I need the accuracy more and less loss. So that is the thing. So I have to maintain the trade-off in such a way. So there are other areas as well, because when you train suppose you don't have the federated learning, normal deep learning. So you know that you are using the optimizer. Optimizer may be the stochastic gradient or Adam. There are several variants of stochastic gradient descent. So you can reduce the variance of this gradient. You can reduce the gradient error. So always gradient error are involved. So if you reduce the gradient error, so automatically it will quickly converge. So this is one of the area you can work on. So how to reduce the gradient variance, how to reduce the gradient error. Okay. Is it clear?
Yes, yes, ma'am. Absolutely. Thank you very much.
Yeah. Ullash is raising hand from the sometime. Do you want to ask something? No, by mistake or what? So Shoaib,
Okay,
I
so
think. Hmm.
I guess, yeah, we can conclude the session over here. And if the participants have any further queries, they can obviously contact Dr. Dipanita offline. So, yes, of course, this has ignited many of the minds, and there are the questions and the interactions shows that. So, with this, we extend sincere thanks to the speaker from the organizing committee on behalf of the organizing committee of this FDP of our university, and best wishes. Thank you.
Thank you, ma'am. Thank you so much.
Yeah,
Okay.
yeah,
Bye bye, everyone.
yeah. Bye. So we will move on to next session within 5 minutes. So just have a pause, not a break, as I say, and don't get disconnected, and just have a pause to begin with the next session. Yes, eminent speaker of our next session has started. Welcome, sir. Can you hear me? Hello. So the first session has just finished. So we are taking a 5 minute pause, sir, and then we will start the session.
All
So
right.
is it okay
Thank you.
for you?
So
Yeah.
we'll start in 5 minutes, right?
Yes, yes.
All
Just
right.
just the session one has finished. So
Oh,
it's a
okay. Okay.
pause.
Got it. Yeah.
Okay.
So
So
it's
within
a
five
tea break.
minutes, we will rejoin. It's
Okay.
a help yourself mode. So
Sure. Of
whatever
course. Of course.
participants want,
All
they
right.
can take and get back. Okay. So, welcome back all for session 2, and the distinguished speaker of session 2 has already with us, is already with us. Welcome, sir, Mr. Urjit Joardar. So, sir, can we start now? So, meanwhile, I just
Yeah, we can start now. So
yeah.
is my microphone working? That's I'm thinking.
Yes, sir. It's working. With the brief introduction, the session will be over to you, sir.
Okay.
So, while I introduce Mr. Urjit Joardar, he is an accomplished engineer and enterprise solution architect. He has been working in the industry for over 2 decades in India and abroad. He has been systems architect, enterprise architect for many organizations, including Health Department of Massachusetts, Ford Motors, Visa, and Siemens. His knowledge on diversified fields and technologies made him appropriate for today's presentation on the topic of enterprise architecture in healthcare 5.0. So we can see that the sessions have been planned or designed in such a way that we are getting to be exposed with the different perspectives of AI in healthcare and precision agriculture. And that is required to get the overall view of the domain, and then we can go in our own way. So obviously with the hope, and we are looking forward to get something different and new aspects or in this session. So with these words, the session is over to you, sir.
Thank you, Ms. Suparna Biswas. So, she did a good job introducing me. So should I share my slides?
Yes, sir. Please share.
Okay, all right. Let me, I'm turning off the camera because light is very distracting here. So in photography, it's called backlight. Okay. So,
Yes.
all right, I'm turning off my camera video. Oh, not this one. Hold on for a second. So the topic of this session is enterprise architecture in healthcare 5.
Sir, your screen is not shared properly.
Oh,
It's
really?
showing
Okay. Let me see. Let me see. Stop presenting. I'm resharing it. Oh, okay. So this is not the one. Let me see. Window. Entire screen. What about now?
It's loading. Now you can go to this presentation.
Okay, sure. Thank you. So can you hear me right now without the microphone?
Yes, yes.
Okay. Let's go to the slide mode. So today's topic for this session is enterprise architecture in healthcare domain, or actually healthcare 5.0. Is it not coming to like a? Oh,
No, it's not coming.
okay.
Now it's
So
coming.
now we can see, right? Okay. Thank you.
Yes.
Do you all hear me? Okay.
Yes, sir, you're audible enough.
All right. Very good. So the topic of this session is enterprise architecture in healthcare 5.0. So when I was a kid, going to school, that time, like I had imagination. I used to think like enterprise means, a large building with a lot of people working in different aspects. And that also comprises like different processes. They are using electronic devices and different kinds of things. Okay. But then, like, my perception has changed slowly. And first, before we discuss what is enterprise architecture, we have to first understand what is an enterprise. What is an enterprise? That's the primary goal, and then we can talk about defining the architecture. Okay, so what is an enterprise? An enterprise is a large-scale organization with composite structure. Enterprise companies often have multiple divisions, each with its specialized functions. So you can also say an enterprise is an undertaking with legal rights to operate business such as selling goods or services. But it's a common understanding that an enterprise generates money for profit or to conduct its operation. An enterprise engages in multifaceted activities such as production of goods or providing services, sales and marketing, accounting and finance, technology, and so on. I can give you some examples of enterprise. You all know though. So Reliance Industries, Tata Group, Siemens, Ford Motors, Boeing Company, ONGC, BSNL, all these are enterprises. Some of them are like governmental, some are like private. But what about like other, some unconventional, I'll give you some unconventional name. You can also think of those as an enterprise, right? Say National Geographic, CRY, Child Rights and Youth, American Red Cross, UNICEF. So do you think like these are enterprises as well? You may or you may not. So it depends on the jurisdiction of where they are established or registered. So whatever be the legal definition based on this jurisdiction, they all definitely need enterprise architecture to function properly and efficiently. Do you agree? So let's go to the next slide. Okay. Now let's get organized to create an enterprise architecture for healthcare 5.0. Okay. Now here, first we need to think what constitutes an enterprise architecture. What are the business functions, activities, and outcomes? What are the domains, information assets, vision and mission, etc. These tasks help identify what services could be implemented and where. What are the desired outcomes of each of these services, activities, and how they are aligned with organizational goal. So, this organizational goal is is a key term. So, you can do different things, amazing stuffs, those are great achievements, but unless it is aligned with organizational goal, right, your task is not fulfilled. So these are the capabilities of an organization. And on the screen, these capabilities are the cornerstone of enterprise architecture and drives defining other architectural domains such as information architecture, application architecture, and technology architecture. So this model is a visual representation of what an organization does and what it needs to do. For healthcare enterprise, I can think of these capabilities on the screen. For defining capabilities of a healthcare enterprise, we really need to get close to those facilities, hospitals, or the admin staffs or clinical staffs, talking to them, understand, talking to stakeholders, understand, and then define the capabilities more accurately. Otherwise, end result may not be as desired. Now let's dive into the domains and the bounded context. I'll discuss that a little bit detail in next slide. So how to derive them from this capability model? The identification of these capabilities that just I discussed on the screen, right, can be aligned, further decomposed to define into more tangible components or services. For example, health specialties. Here health specialties. I'll just take one example, and then I'll drill down, at the low level. So for example, health specialties is one of our capability, and let's see how we can further decompose it. Okay, and for this decomposition, we do some exercise like align and discover. I'll discuss in detail. For example, if we consider, here oncology domain. I cannot see my cursor. Okay, so this oncology domain, right? I just pick anyone. So this oncology domain, say if we can further divide it, we can further derive or decompose it to more granular levels from this oncology domain. Okay, so for this decomposition, we do some practices, we do some exercise. This is how we align. From this oncology domain, we can derive it further, and we get like subdomains like medical oncology, radiation oncology, and so on. From these subdivisions, we can further decompose it into more specific subsystems, which might serve a singular purpose. At this level, we are already attaining the bounded context. So what is a bounded context? So bounded context is, you can say, it's an independent module with some boundaries. Okay, with some boundaries of what they do, and that provide a specific service. More often than not, these are deployable units and can be thought of like microservices. Microservices is a special type of architecture. It's an architectural style. So I'll not be discussing microservices in detail here. I'll save it for like next discussion. So with the completion of this level, right, we are already attaining logical deployable architecture. How? These are like domains. These are like domain of, come on. Yeah. So from the top level, you see like level 1 is like a capability, right? And capability, you are decomposing it further to more granular level, and you are actually attaining the more defined levels. And from those defined levels, right, you are further decomposing it to basically, basically services. And these services, you see the bounded context here. These bounded contexts are basically, you can deploy it as a service or a module. Here, this is our structural model. This is our structural model. So this is, you can say, structural model or physical architecture, structure of our application. Here you see like the top level. Top level is our front-end application. Front-end applications are, all these front-end applications that interacts with user lies on the front end. These applications, that have, I try to keep this front end. Within the front end, I have like two layers. One is presentation layer, one is application backend. there is a pattern called BAFF, backend for front end. So I'll discuss that later if needed. So here, the presentation layer is basically what users can see, on their computer or laptop, or any kind of PDA devices, tablet or anything. The reason for keeping this in 2 tiers is to enable us to reuse our code more efficiently and flexibly. The web backend, see the web backend here, or the application backend, it can communicate with the core domains to exchange data to and from the core services and deliver data to the presentation layer. So these are applications, these applications are deployed on the web server side. Okay, so this is not the HTML pages. This is where your JavaScript and your could be some front end application could be there, and these applications are talking to this layer. This is the core domain. You can say it's a business domain. Okay, that's what we say. In our work, that's what we say. It's a business domain. And this, the reason for keeping this presentation layer separate within the front end is there are several reasons, right? Sometimes, like what you see on the screen might depend on which device you are using. Say you are using a desktop computer or laptop, or say you are using a tablet or phone, right? So the screen real estate changes based on the device. Also, based on the browser, some browsers have certain capabilities, some others not. Or it could happen like even for different authorization level. For different authorization level, you can deliver different information to different individuals. Say for example, what a doctor can see may not be available to a nurse or some other hospital staffs. And here are the at the bottom we have infrastructure module, and these modules are say IAM, identity and access management. Then we have broker mediator like Kafka, IBM Service Bus, Mule, etc. We also have AI modules. We also have blockchain modules. This is I represented by DLT, distributed ledger technology, or blockchain, you can say. No, blockchain is not exactly DLT, distributed ledger, but I just represented it as DLT. And we have other modules that we do not know yet. Many places I put question mark. Why? The reason is I'm not a doctor, or I'm not a healthcare professional, so I may not know what are the domains, or what are the how they perform actually. What are the granular domains and how they perform. So I need to find it out. I need to find it out by talking to the clinical staffs, the admin staffs, and other staffs in the hospital or any other healthcare facility. So next, in my next slide, I provided some activity diagram for demonstration purpose only. But before I go to the next slide, you can see that, with this kind of arrangement, any module at the upper layer can talk to any services or module in the layer below across the environment. These layers also provide a clear separation of concern, of responsibilities, like the front end layer where the application where the application is sitting there. The sole responsibility is the user interaction. Here in the business domain or core domains, that is where we are processing data. we are processing data or fetching data, all this kind of stuff. And infrastructure, I did not include database here. I should have, but I'm just, this is like a, it's a concept. I'm just sending you a concept. So these infrastructure modules are, they don't change often. They don't change very often, but they might. But the reason for infrastructure layer is like they are available as as infrastructure. You can say like as an infrastructure. That's why I name it like infrastructure modules. What changes? What most of the time, what changes is like in the front end applications and the business logic. Business logic are in the business domains, the code domains. So let's move on to the next slide. See, here it's, I cannot move that slide here. See here in this on this slide, I defined different capabilities and components. These components might be deployable, like if it is already derived and decomposed at the granular level. So those are the components I will use. Those are the components I will use for any kind of activity. So let me see. Okay, so this is basically, it's a, I can imagine, it's from my imagination. We can think of an activity of a patient coming to an emergency and admitting to a hospital, and then getting treatment and then getting discharged. Okay, so what is it? Patient is coming to the hospital. You can think of this workflow. A patient comes to the hospital. They are in the emergency department first, and before they are admitted, they get admitted. Usually there is an evaluation. There is an evaluation of what might be the cause for his pain or the suffering. So for that, they might do some kind of diagnostics. So they can use MRI, CT, or some pathological test, and they do the evaluation thereafter. And I'm just first defining and describing the flow. And after evaluation, there can be two scenarios. One is like, is that patient needed an admission, or they may not need an admission. They can discharge that patient with just prescribing with some prescription. Okay, if the patient needs an admission, then there is a bed management module that comes from my previous slide. So that is needed. Which department, which floor, which bed is available, and then they get admitted. Sometimes, many times, like when a patient is admitted, they often get like some kind of reports, some pathological or say some radiology reports from other hospitals. So for executing the treatment, this hospital or healthcare facility might need those reports. So how do they do that? That's where like we can use distributed ledger or blockchain. The patient health data is very private, and it is most private in US and probably in India too. So we can leverage this blockchain technology for a secured data transfer, and also keeping track of like how many times it got transferred from different places, and who has access who has already accessed this data. These kind of records will be there. But then, like, after getting after receiving those reports, patient can undergo through PET scan or some other kind of treatments, and then there will be prescription, and eventually they will be discharged, right? So let me go to the other slide. So this is an example of a system of remote monitoring a system, remote monitoring a patient. So sometimes, like, many times you see, like, patient gets discharged from hospital, but they come home with a device, electronic device, and those devices are basically IoT devices. So even, like, for heart monitoring, those devices, those are like constantly attached with patient's body, and that generates data from say a patient's heart condition. Okay, and those data is transferred to our hospital or our healthcare system. How do they do that? They use basically radio frequency network, or say not only radio frequency, but even they can be used. They can use some mobile network to send those data across. And those data, like, say, we are not say if we are thinking of like a enterprise application, right? So we are thinking of deploying this application for all over India. So we are not just monitoring one patient. There can be hundreds or thousands of patients across India. And how to keep those data safe, and then those datas, we should keep those data safe, and then, like, fetch to our application for further processing. And for that we use Kafka, Kafka, or say uh, message bus, this kind of services. And this Kafka, the Kafka here, that is from our core components. We make use of one of the core components here. And then, I said, like, for easier deployment of this kind of system, we also have some source connectors. Source connectors are basically software component that automatically fetch data from patient devices. And most of the cases, like, it will not come from directly from the patient devices. It will come from um, it will come from, most of the time it is from the cloud. So patient data, patient heart or any kind of health data will be transferred to cloud via edge locations, and then we can fetch this data from our cloud to say a broker, or any kind of mediator, and then that data is eventually will be transferred to our process. And see here, it's a source connector. On the other side, I have sync connector. Sync connector is basically, it will fetch data one by one or in a group to our processes. The consumer group here is basically constantly monitoring if any new message is coming to our broker, and those messages will be picked up and processed. And the application code, let me go back to previous slide. The code here, say neuropathology, or let me go back to here. The slide is moving very slow for some reason. So, for health, in my health specialties, I have cardiology, neurology, pediatrics, and different kinds of domains, right? So these are basically deployable components. These are the deployable components at the granular level, and these are the codes that we write and basically executed here at the consumer. So consumer receives message by batch, or a single message or by batch, and deliver it to those individual modules, the codes. And most of the time, it is better to use microservices architecture. Common notification module, recipient. Okay, all right. I'll not discuss more about this. Let me go back to previous slide. Okay. Oh, I should have shown you this slide earlier. This is like a patient appointment notification. You book an appointment, and before appointment, maybe a day before, maybe 2 hours before, you get a notification. You get a notification on your cell phone, or or on your email. So how does it work? Say for an hospital or any healthcare facility, we have a scheduler deployed. Scheduler is basically, it triggers event. It triggers an event, and how often that you can configure. Okay, so based on those events, the process will fetch data. What data? What is the relevant data? Relevant data means, like, if you set the scheduler for, like, a day prior to the actual appointment, right? It will calculate, compute, and fetch all the data, for the appointments, for all the appointments for the next day. And if you think, like, you want to send this notification 2 hours prior, so you will configure it. You will configure the scheduler, the way it's needed. And I said, like, retrieval apps. So here in this retrieval apps, this is basically, here it is like a fetching operation is happening. Retrieve database chunk messages, and this process retrieves data chunk by chunk, relevant data chunk by chunk, and send it to a Kafka broker. And on the other side of the Kafka broker, you have consumers. That's where your code resides. Consumers, it may not reside directly on the consumer, but consumer will receive it and send it over to say your microservices. And in this case, we are sending notification, right? So what data we need? Patient's name, contact number, email address, what kind of message, what kind of appointment, and we send it to a notification service, right? And notification service, say notification service is a service which evaluates the patient's preference. I'm just giving you an example. Say notification service will evaluate patient's preference, like, how would they want to receive these messages. For example, some patient may prefer receiving those messages in email only. Some patients might want to receive those messages on their cell phone, or both, right? So these data is processed, and from this, you see like a JSON here. You see a JSON here. From this JSON, this notification service creates the message and send it to the desired destination of those patients. Okay. So you see, like, from the capabilities which we can define, which we can basically find out the capabilities and define those capabilities, and from those capabilities, how we are decomposing it further to, like, individual modules. We can, from those capabilities, we can find out the domains, and from domains to subdomains, and from subdomains to like bounded context, and those bounded contexts are deployable services, deployable components or services. And we also have seen like how those how our code will um, how our code will be deployed in a physical on a physical architecture level on the hardwares basically. And the layers, how the components are deployed in different layers, so that each layer can serve a single purpose. Okay, and let me go. Next is like TOGAF. I'll come to that later. So, and also like you see. Let me go back to this previous slide. See, we have deployed some API gateway here. API gateway between presentation layer and say code domains, and even presentation layer to application layer, the application backend, and application backend to code domains. So why is that? Because by deploying this API gateway in between these layers, we make sure certain things. We make sure certain principles. I'll discuss about those principles in a little while. Those principles are met. Those conditions are met. On this API gateway, we deploy, say, logging, then security, then governance. These kind of conditions we can deploy in this kind of API gateway instead of writing a separate service, so that any communication between layer to layer can be tracked. And why is it needed? It can be needed for several purposes, such as, say, security is definitely one. Other could be like the performance of the application. Sometimes you hit a bottleneck, and then you might deploy more hardware. If you are on a cloud, and most of the time these applications will be deployed on a cloud if it is a nationwide application. So you might need to deploy or include more compute, or say more IOPS for these things. I have, or mostly most of the places they deploy API gateway, and it's easy to deploy through API gateway because it has a mechanism like the already available API gateways on the market. It has a mechanism to trigger event and capture those specific data. So these are the two frameworks. Like two frameworks means one is TOGAF and another is Zatman. These are not specific to healthcare 5.0, but these are generic framework. These are for guidance. These are for developing any enterprise architecture for any organization. I'll not discuss this in detail because this is a considerably large kind of the content of this topic is a separate topic and it's a large discussion. But I basically I filtered, distilled, and delivering you more concrete, understandable solution. So all these solutions, whatever I presented, are taken from some of them are taken from TOGAF framework. Some of them are from Zatman framework. This presentation includes a combination of both. You can read on this, because I also do not think like we have any questions for you from ADM or say for Zachman framework. But throughout this process, I mean, any enterprise architect will definitely follow some principles. We have a list of principles. Like actually, I've distilled and filtered some principles from both these frameworks, and I'll discuss it like right now. So what are those principles? What could be those principles? One is like, say, intentional design. What is intentional design? Intentional design should be strategic, should have readability, maintainability over short time, over short period of time, or long period of time. And intentional design also means like your design should be always aligned with the business goal, because it is all about business, whether for profit or non-profit, right? Another could be like, say, always always adopt service-oriented architecture. Why? Because service-oriented architecture will help you to decouple, the system that uses service-oriented architecture for decoupling, adaptability, extensibility, these kind of advantages. Of course, design for user experience. And also it is very important to understand the holistic change, the impact of the holistic impact of any kind of change. Because once you deploy an application, right, any business, whether it's a healthcare or any other kind of business, there will be changes and there will be bugs. So if you fix a bug, or if you incorporate any changes anywhere, right, what is the impact? What is the impact of the rest of the system? That we always have to keep in mind. And one of the reason the industry is adopting microservices architecture is like to minimize those impacts. Microservices are services which are independently deployable, and if you make any change to any microservices, right, it will have minimal impact on other microservices or other kind of services in your entire ecosystem. Other kind of principles could be like, enable data collection. Enable data collection. Why? Because you collect performance metrics, and based on those performance metrics, how is the load right now. Or you can also deploy some machine learning or AI module with this data collection with this data collection principle. Not the principle, but you can also deploy some machine learning algorithm on the data collected already. Constantly data is being collected, and based on that you can do some forecast, the prediction. Say for example, like you might see with those AI modules, you might see the the patient needs increases in certain seasons, right? So you can always have data collected on your system, but you'll not be able to analyze this kind of this kind of you cannot analyze and predict this kind of demand. Okay. And of course, like always, security is in mind, whether your system are scalable enough. Then you always have to follow industry standard, because if you follow industry standard, right, help is readily available. You also have to keep in mind, like you have to deploy a system so that you can upgrade that system seamlessly without any pain. Also, other thing, like for large enterprise, they want to minimize the software dependency. Say you are using a third party software. Okay, so whenever in an enterprise, whenever they deploy a third party software, they always define the exit strategy for employing a third party tool or software, because so that they are not tied with that particular tool or with that company forever. What else? You also have to architect for business growth and changes. That is obvious, because it's never been like you write a code once and that will serve the purpose forever. Business, even including healthcare, it is always changing, and there will be changes in your code. There will be new technologies. There will be say an upcoming domain, or even for like a the healthcare facility might wants to include some domains or subdomains. Say maternity, they want to include maternity, so there will be changes in the system. So your system has to be architected in such a way so that it can adapt, incorporate those changes very easily. Also, while you are architecting, another thing always there is like the cost of ownership, the total cost of ownership. You can do amazing things. Say you probably can develop an amazing AI algorithm, or say you can propose, or for your research you can propose a theory for security or blockchain, or say some technology similar to DLT, the distributed ledger. Okay, you can do amazing things, but we always have to keep, for enterprise architecture or for an enterprise architect, always keep in mind, like the total cost of ownership is very important, because whether your organization is um, is ready to invest, or um, even if they want to invest, those kind of questions are always in mind, because every project there is a budget. Okay, so you have to, everything comes under enterprise architecture. So these enterprise architects are basically business partners. Like partners means they are the business stakeholders from the technology side. Okay, and if you incorporate, or if you track these principles that I talked about, right, you can also, I have 25 to 30 such principles, and if I just follow those principles and employ it in any kind of enterprise architecture, different aspects are already covered. Different aspects are already covered with these 25 say principles. Okay, so what are those aspects? In industry we call it like lenses, architecture, view through lenses. So what are those lenses? A lens that says, like, decisions, the decisions you are making that impact customers, the decisions you are making that impact scalability, the decisions you make that impact reliability. Okay, or say availability. So these are the thoughts you always have to keep in mind. And if you follow, if you follow your principles, then most often than not, like, if you have implemented, or if you have implemented, say, one principle that may cover two or three of these aspects of your architecture. For example, like I said, like enable data collection is one of the principles, I always keep in mind. If I follow that, it will it will it will serve two purposes, two or three aspects of the architecture. One is like reliability. Why? Because you can enable data collection is basically collecting the usage data, the performance, and you can derive performance metrics, and you can also deploy AI module on those collected data to forecast. You can predict the the load on the system, or what time it goes up and what time it goes down. So if you have, say, for example, enable data collection, if that condition is met, right? So that what does it suffice you? It will help you to scale your application. It will help you to make your application more reliable, or even your system is more available. Say, for example, if you adopt service oriented architecture, it will help you to scale your system, because using service oriented architecture, say you have microservices, that is also like a kind of, it is derived from service oriented architecture. So these microservices, say you have one microservice, one instance of a microservice, right? And whenever the load increases, or even like from your AI module, you can predict when the load will increase, and you will automatically instantiate couple of other microservices instances on the cloud. Or when the load is like, say, low, let's say midnight or some other time, you can reduce those the EC2 instances, or kind of VMs. So if you follow, or if your principles are met, so that will cover multiple aspects of microservices. You can read through this a little bit, not needed for this particular session. Now I'm open for questions. If you have any questions, you can ask me now, or you can send it to Mrs. Bishwas, and I can
Yes.
like.
Yes, sir. Okay. So now interaction is open.
Mhm.
Hello.
Participants have a question, please raise your hand.
Sir, what we can do is we can take questions offline.
Yeah. Okay.
And your slides are with us, so we will share with the participants,
Okay.
and we will share your email ID as well, so
Okay.
they can take the questions and the interactions offline as well.
Okay.
So
All right. Not a problem.
yeah, thank you so much, sir, for this
Presentation. Yeah.
informative and completely focusing on the different perspective of healthcare from the enterprise and architecture point of view. So hopefully the participants will get the useful things from it. Again, they will go through the recorded session that will be shared with all, and also the PPTs will be shared.
Sure. Thank you, Amit,
So
for the compliment, and thank you, Mrs. Bishwas, for the compliment. And have a good night, or maybe have a good
yeah,
day, wherever you
yes,
are.
yes. So Yeah, we extend our sincere thanks to you on the behalf of the organizing committee of the FDP
All right.
that is being organized in our university and funded by ATAL scheme. So thank you once again and good night to all participants. The feedback link and feedback come attendance link has already been shared. So you do not fail to fill it up by 11 p.m. today. That is mandatory and use your registered email ID. So with this note, thanks to all and we will look forward for tomorrow's session at 6 p.m.
Thank
Good
you.
night.
Good night. Bye.